G'day guys, as the introduction goes, I am Robbins Kariseb. I am a development lead, which basically means I will be responsible for ensuring that an entire team delivers an entire project. We have done many projects including Paid Today, I don't know if you guys saw it. That was done by Adair Technologies. I did my bachelor's at Harvard, that is Harvard University. I am busy with my master's degree, same institute. So the objective with some of these projects that we're doing is to ensure that within the Namibian context, we have software that we can be proud of. That's what we're trying to do here. So ultimately, I'm going to get started. This is one of the projects that we're busy with at Adair Technologies. It has to do with a few technologies that we are really proud of. One of them is the Matrix platform that we are using. So Matrix is sort of like a communication protocol, much like you would use HTTPS to send information from a server to a client and vice versa. Matrix has a very specific protocol that ensures that information that's sent between server and client is encrypted end-to-end. So the E2E standard essentially means that before the packets or before the information hits the network, every single thing is encrypted. So if you're a sniffer trying to extract data from a network perspective, you won't be lucky. In fact, if the person on the other end loses their phone, but they're signed out of the account, you won't be able to access any chats. So this is the protocol that we use to build Adair Messenger. I think it's an incredible product. We are moving fast with it. We already have our first client. So we are basically going to ship this in a bit. But yeah, let's get started with the presentation. All right, so with Adair Messenger, much like any development team, we had problems. The first deployment that we did was for a small company called Press Zero, I believe. So Press Zero was a UK client. Essentially, they wanted a chat application that will enable clients to communicate with other businesses. The project had its challenges. I think one of the primary challenges was we had maintenance nightmare because we pretty much built the backend in Python by ourselves with a custom WebSocket. We thought we were cool, but then we realized that maintaining such technologies, especially if it's not proven, is very difficult to do, right? So that was the first problem that we had. The second problem was the security burden. Like for example, Matrix would use the E2E standard. We were not compliant with this standard, so we couldn't sell to UK companies, which the data sovereignty and data privacy regulations are very high. So due to that reason, we swapped it out with the metrics, metrics.org backend, and this helped us a lot, I believe. The second to last challenge was scalability. As you can imagine, if you're going to build a backend in a monolithic fashion means that the backend has one start button, right? And once you hit start, the entire thing goes up. So what we're using right now is called a microservice architecture, which means there are 5, 10, 50 start buttons. Each process runs on a separate thread. In fact, in a separate process, which means there's segregation by default. So these systems are incredibly fast. I think most of the fastest systems right now are using the microservice architecture. So this was one of the benefits that we got because we were able to deploy matrix.org as a microservice in the backend, and the chats that we were doing essentially was able to sort of like be faster pretty much, because remember we're using end-to-end encryption. Each chat message has to be encrypted and decrypted at rest. And okay, so at rest it's encrypted but decrypted when it gets to the client pretty much. So that was one of the things that helped us with. The last thing, I think, for smart people is very difficult to accept, but you don't really have to reinvent the wheel. Just because you can build it doesn't mean you should, right? So I think that was another slap in the face. We, like I said, built a custom WebSocket, which was basically responsible for relaying messages between the client and the server. We didn't need to build it. There was already a proven solution that was out there. So with Adair Messenger, what we did is we leverage all of this, and by incorporating with metrics, we leverage all of these challenges into solutions, pretty much. So let's move on. So the architecture of Adair Messenger, this is from a high level, so it's basically simplified, because we didn't want to bore you with too many complicated nodes and stuff like this. So at the top level, we have the Matrix Synapse server. If you guys want to build something like WhatsApp, I would recommend starting with Matrix Synapse. So this is a open source protocol or an open source application or backend that you can deploy as a microservice. And like I said, the microservice is just sort of like a computer within the list of computers that you can deploy to do some work or get some work done, right? So we leverage it as the backbone of our communications. So everything that is sent or received is handled by Matrix. Matrix, it's not here on the slide, but Matrix has its own Apache Kafka PubSub framework. So some of these terms are really complicated when it, like all it's saying is every time the server receives a message, every time someone publishes a message, it needs to send the message to all subscribers. So let's say I send a message to a group. I'm the sender, I'm the publisher, and you guys are the subscribers. You guys are subscribing to any message that I send. So every time I publish, you will be notified. That's all it means. On top of that, all we introduced was our own Redis PubSub. Same principle. So every time Matrix receives a message, we just relay it to all listeners, pretty much. So that's what we did. So all in all, I think Matrix saved us around about 6 to 12 months of development time if we were going to build something that's that secure and that proven. So yeah, I would definitely recommend, especially for people that are trying to build chat applications for commercial purposes. Like for example, if you're trying to replace Microsoft Teams, which is one of the biggest systems that we have. What's also not on the slide is something else that we're using. So the application is able to do video calls. So we use something called WebRTC for that. And we just integrated this WebRTC framework into our PubSub architecture. And it works well for us. But yeah, enough of the boring stuff. I think I covered most of this. Basically, this supports why we had to use Matrix. Now, like I said, the last point that the challenge that we had was reinventing the wheel. Matrix has a very huge community, which means there's developers out there that are probably even smarter than me, that are battle testing some of this security risk that arises with any application. I believe most applications would have security flaws. I mean, Microsoft Teams had it, Google had it at some point, but battle testing enables us to sort of like get rid of the issues quickly. So if a lot of people use it, a lot of people can find out what's wrong with it and then fix it, pretty much. That's the principle. Let's move on. I'm gonna try to explain, because I know that you guys might be interested to find out how this actually works. I'm gonna try to explain what happens in the life cycle of a chat message. So what happens when you send a WhatsApp message, pretty much. So this system is actually built quite similar to WhatsApp in that it has end-to-end encryption. But what's also similar with WhatsApp is that it's able to ensure that your messages can only be read by you, right? So what happens? I think Let's have a thought experiment. I know that most of you were in trouble at some point in life. Like, for example, you did something that you didn't want your mother to find out, now you're in trouble, right? So if you're the only one that knows what you did, your mother wants to find out, but you're the only one that knows what you did, the information is at rest. This means somewhere in your brain or your mind, that information is stored. The only way your mother's gonna find out is if she hires a clinical psychologist that sort of like hypnotizes you pretty much and gets the information right. Otherwise it's not going anywhere. So just like that principle, in computer science we have protocols that prevents attackers from getting information that they are not authorized to see, right? So in this case, your mother is the attacker. She's trying to find out who broke what, right? But the protocol that God created in your biology prevents her from doing that. She needs to literally hire a psychiatrist to try to figure out what you did. So the point here is, information at rest is actually relatively secure, right? So long as your mother doesn't get a psychiatrist, she's not gonna find out what happened. The problem happens when you share the information with a third party, like you told your brother, and you know that you snitched on your brother 2 weeks ago. That information is getting out. You know this, right? So when information is now shared with a malicious third party, like for example, you paste some API keys in ChatGPT, we got a problem, right? Because now you shared your critical information with a third party, so the chain of access is sort of like violated. So now it's not just you that knows this information, it's someone else. So what Matrix does is it verifies, secures, and validates that the chain of access is never broken. What do we mean by that? Well, we mean each device will start with an encryption key. So each device will have a secret key that they will use to encrypt the messages before they send it on the internet. When the information is on the internet, you can see it's scrambled. It's just hashtags and @signs. You don't actually know what the information means. When it hits the server, we don't decrypt it, because we can't. It was encrypted with a secret key by party A, right? Client A encrypted it. Now, when client B requests for the information from the server, we have to send the encrypted information. Because remember, we can't decrypt it. We don't have the keys. Now, when party B gets this information, they have their own secret key, which the two parties agreed when they started the chat to use to decrypt the information, right? So now, party B will know how to decrypt this information because they have the secret key to decipher it. So deciphering just means you're taking all that scrambled text and then you're converting it into its original form. Ciphering means you're taking the original form of information and then you're scrambling it so that the attacker can't see anything or they can't make sense of the information, pretty much. So that's what's happening in the back end. And Matrix enables us to securely do all of this. Sorry, I hope I'm not going fast. Are there any questions on this? All right, so I think we went through the reasons why we had to sort of like adopt Matrix, right? I think we can skip this. I want to speak a little bit about encryption and its origins. So cryptography, I think the original term is called cryptography, right? So cryptography was started in about 1900 BC, right? So I think in order to understand why it was started, we need to try to understand what it's trying to solve. Like I had the analogy about the mother that wants to get information from her daughter because something was broken. Information security has always been a risk. So if the first military is about to attack, if the second military that they're attacking knows when they're gonna attack, you can see that it's a problem because they'll be prepared when the person actually attacks, right? So to prevent this, I think it was started in Egypt where they started ciphering information. But it went all the way to, I think, Spartans. They really perfected it because Spartans have this swirly way of, they sort of like wrap a paper around a pencil or a stick, then they would write on the paper. Now if you unwrap it, you cannot see the text. You cannot see the intention of the text, essentially. So they started doing that, and then Caesar, I think, created one of the most perfect ways of encrypting information for about 100 years after that. So Caesar cipher, it's called. What Caesar cipher does is it'll take text and then it'll shift it by a certain number of characters in the alphabet, right? So for example, if you are encrypting the letter D, you have to shift it by 3 according to Caesar cipher. So A, B, C, D, E, F, G. So D will become G, pretty much. And that's going to be done for every single text on a document. So that's how Caesar was able to cipher information, and when they were fighting war, they would be sending encrypted information across the entire army. So yeah, I think ultimately what we at Adair are trying to do with this project, and what I think that most of you guys can learn from, is that information security is actually a vital subject, especially for governments, for banks, definitely for banks, and for organizations that hold information sovereignty as a high priority. So Europe is already getting into this rhythm where information sovereignty is one of the highest priorities. There are other countries that are also adopting it, but from a government stance, I think it's mostly Europe. But yeah, that is my presentation. I hope you guys enjoyed it. If you have questions, now would be the time to.
Thank you very much. So, now I've got a microphone for questions, so I'll run around the room for you on your behalf.
Okay, so I have a question on the matrix, something. You said there's the communication, the two parties involved in the communication, yeah, client A and client B. So they both have keys. But then, like, what if, like, is there a way to prevent attackers from still intercepting the data? Because attackers can still intercept the data and then they can steal the data even if they don't know how to encrypt it, or they can still add some stuff to the data, or like basically they can still access the data somehow. So is there a way to prevent access even if it's encrypted?
That is a brilliant question. I think the fundamental question that you're asking is something like, is my data secure if someone accesses it even though it's encrypted, right? So I think my answer to that is yes. Now, the reason why I'm saying this is Matrix uses a 32-bit cipher to the power of 2, right? So, okay, so it'll be a 32-bit cipher to the power of the room size. So if it's 15 chats in the room, then it'll be a 32-bit cipher to the power of, what, 15? Because every single encryption key is basically used to create a unique string that keeps the sovereignty of the data intact, right? So for that reason, I would say, I don't think you'll be able to access it. In fact, if I am to lose my key, I won't be able to access my historical chats. So it's heavy security. I think this is trusted by banks and governments in the UK already. So it's very heavy security. Okay, so
a follow-up question is, like, you spoke about Caesar cipher, which uses like a shift of the letters. So what cipher does Matrix use?
That is a good question. I think Malloc, let me just verify, it's called Malloc. They have their own proprietary cipher, which means these guys had the audacity to come up with their own encryption algorithm. So, I think it's in one of the slides. Let me just verify. Yeah, it's Malloc. I'm going to just confirm that, but it's Malloc. Yeah.
My question is, you see in WhatsApp, right? On the WhatsApp app, like you can log in with, you can log in your account on someone else's phone, right? Am I able to do the same thing on Adair Messenger?
You see, this is where Adair Messenger stands out. Arguably, and this is like when you're doing academic writing, you need to use your terminologies right. This is what I'm saying, arguably, right? Arguably, this is one of the most secure. It's probably more secure than WhatsApp, in that even if you sign in, if you do not use your recovery keys, you won't be able to access your historical messages at all. So no, you'll be able to sign in, but you'll only be able to see new chats.
So your old data that you had before is lost?
No, it won't. Okay, so what you do when you sign up is you generate a recovery key. So the recovery key is a 32-bit string or whatever that sort of like stores information about your historical chats. So that's the key that you need in order to decrypt your historical chats. So when you sign up for Adair Messenger, the first thing you do is you generate a recovery key, you save that, keep that somewhere safe. If you lose it, you lose your historical chats.
Okay, my question is, what protocol do you use in the messages, Adair messages? Because I know for websites we use HTTP, so now what protocol do you use here?
Yeah, that's a very good question. If you can check on the top, it says WSS. That's called a WebSocket. So most of you guys are familiar with HTTPS, HTTP, but there are other protocols pretty much. So WebSockets use something called a WSS protocol. The final S is for secure. So if it's insecure communications, then it would be WS.
So my question is, you said that it's like end-to-end encryption, and it's like WhatsApp. And for you to access your historical data, you need keys. So now you also said something about when client A and client B are talking to each other, client B needs to have the key to access whatever client A sent to client B. So, but I just want to confirm whether it's like, there's this game called DLS, Dream League Soccer League. And let's say you want to play someone online. You're going to have to create like a password or a key that you both have to be the same for you to be able to play together. So is it something like that?
Yeah, it is in fact something like that. In fact, it's one layer deep, right? So you described its two-layer architecture. There's a third layer. Those are called public keys. So publicly, you can broadcast them, but you need additional information to make sense of it, right? But there's a private key on the server, which means that if the attacker doesn't have access to the private key on the server, they won't actually be able to do anything. But you are right in saying that both of them need those keys in order to partake in this joint conversation. It's exactly like that.
Thank you.
Another question? Pass it down to Amy, please.
You talked about third-party apps getting access to these things. What type of apps are you talking about, just so that we can know what exactly to avoid?
That's a good question. All right, so I'm going to answer that in two parts. I'm going to answer that in context, right? So I'm going to give you some context. My master's is basically in AI. And I am not really happy with where we're going. In that the people that are not informed do not actually understand that we are training potentially sentient beings, especially if we have something close to super intelligence. So what you're giving ChatGPT every single day is the ability to not just not just learn from your data, but to replicate your IPs. So what does IP means? IP is intellectual property, right? So if you're working for a big company, every single code or every single implementation that you do is called, it falls under intellectual property. This is why you can't take your company's code base and then go start your own startup, you'll get sued. So what we are effectively doing is we're training these potential sentient beings, because right now we have general intelligence. ChatGPT is an example of general intelligence, right? So general intelligence is just to get them to do their research. So right now they are researching on our data. They collect data, they collect information, they do their research, and then they will start deploying super intelligence. Now, super intelligence is a step higher. It's going to be smarter than any human. I don't think we'll be able to compete with them. So this is why I want to start there. So when you paste your sensitive information, for example, into ChatGPT, you're giving people access to your proprietary information. Secondly, even with WhatsApp, when you switch phones, you just enter your phone number, yada, 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 you get a notification, SMS, yada, 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 you feel happy, you have a new phone, you migrate it. How were they able to decrypt your historical chats? They're storing it somewhere. And if they store it, they can decrypt it. And if they get decrypted, they have access to your messages. So the point here is, do you actually trust the service providers that you're using? And therefore, my argument here is that Matrix protocol is probably one of the most secure because it gives security back to the user. We don't deal with your encryption keys. If you lose it, it's your problem. But at least we stay out of the conversation.
Hi. I have two questions. Can I ask one of them? Okay. So the first one, let me start with the bigger one. So before I started doing grade 10 here in Namibia, I was doing grade 10 in Angola. And we have like a course called Electronics and Telecommunication. We don't have it here in Namibian high school. I was doing like there in grade 10. And I kind of got confused when I came here because here you don't go directly to your course. You have to choose per subjects and all those things. So I just want to know if electronics and telecommunication, you said your company or the program that you developed is literally a messaging app. And I just want to know if this electronic and telecommunication, if it's applied to what you just constructed, to what you just created. And my second question is like, what are the protocols for when I lose my phone and the app is on my phone? What can I do to get back to my account if I don't have the keys, for example? Thank you.
This is